Hi everyone, welcome to YourPedia. We already completed with the first chapter previous AAI-ATC exam questions which were asked from till 2023. We completed the first chapter. Now our second chapter is current electricity. Yes, now we are going to solve all the previously asked questions from the chapter current electricity. Yes, let's get into the questions. We solve each and every question in a very clear manner. Yes, very clear manner. What he says, if a current of 18.2 amperes per second, he given current per second, so that amperes per second. See, what is current? Current is I equal to solution. I'll be doing here. Solution is already there. Okay, already there in this, but I will explain you what is the solution very clearly. Yes, solution. What is given? Current is equal to Q by T, but he given what? Current per time. He given what is that? Q by T square he given. Yes, Q by T square he given. How much is saying that? He is saying that 18.2 amperes per second. 18.2 amperes per second flows through a copper conductor, and the average collision time of electron is 0.25 microseconds. So tau is equal to 0.25 microseconds. Clear? Then the value of conductivity of the copper is, he is asking about the conductivity. Yes, the direct formula for conductivity is N into E square into tau by M. All of you must remember this formula. Conductivity of any conductor is sigma is equal to N into E square into tau by M. Now let's describe what is this N, E square and tau and all, right? I will write this formula as N into E into E, NE into E into tau by M. What is NE, sir? NE is nothing but this current per second. How much he given? 18.2. Where E is the electron charge. E is the electron charge. What is the electron charge? 1.602 into 10 to the power of minus 19 coulombs into tau. This tau symbol is a special symbol I taken to represent the collision time. How much it is? 0.25 micro means 10 to the power of minus 6 by M is the mass of the electron, that is 9.1 into 10 to the power of minus 31 kg. Right? You all know that. How much it is? 9.1 into 10 to the power of minus 31 kg. You solve this numerical, yes, you will be getting the answer, and the answer is 0.80 into 10 to the power of 6 mhos. Yes, per meter. Yes, conductivity. Resistivity means ohm meter. Resistivity is ohm meter. Conductivity is mho per meter. Right? Simple, direct formula. So one thing every one of you must remember here is this conductivity formula. Conductivity. If you want resistivity, yes, resistivity and conductivity both are reciprocal to each other. Yes, this is resistivity, right? Yes, simple question, direct formula based question. The very important thing here is doing this calculation. You must be in a position to do that calculation, in a very simple way, within the given time. Do not waste your valuable time in doing the calculations by taking more time. Okay, you must learn in such a way that calculations are going to be done within less time, right? Let's go to the next question. Second question. What second question he is saying? Let's read the question first. Two batteries EMF E1, EMF 3 volts and internal resistance 0.5, E2 6 volts and 1 ohm are connected in series by connecting the positive terminals of the E1 to the negative terminal of the E1. See, negative terminal of the E2, please. Why both will be E1 only? Yes, yes. Now what he is saying is E1 and E2 are connected this way. E1 and E2 are connected this way. I am solving here. What is saying? This is E1, yes, this is E2, yes. Positive terminal of E2 is connected to the negative terminal of E1, yes. What he said? Are connected in series by connecting the positive terminal of E2 to the negative terminal of E1, okay, yes. And the third battery of EMF E3 is connected is connected, yes, how much it is? 6 volts and 1 ohm in parallel with this combination. In parallel with this combination, continuation statement is there in the next page, it seems. Yes. Now observe here what he is saying, in what way it is connected. With this combination, by connecting its positive terminal of the positive terminal of the E1 and its negative terminal to the negative terminal of E2, means what he is saying. This is E1, sorry, this is E1, this is E2, and positive terminal of the E3 to the positive terminal of E1, and a negative terminal of the E3 to the negative terminal of E2. So this is E3. What are these values? 3.5, this is 3 volts, this is 0.5. Yes, how much is this? This is 6 volt. How much is this? 1 ohm. And how much is this? This is yes, how much is given? 6 volts. This is 6 volts and 1 ohm. Now what is this question? What is expecting from us? The equivalent EMF of this combination is dash. The equivalent EMF of this combination means, sorry, I need to go to the previous page. This EMF we want. This is the EMF he is expecting. We take that one as voltage with plus here, minus here, with plus there and minus there. We learned in our classes that, or here itself we learn, voltages in series will get add, currents in series parallel will get add, but that addition is going to depend upon the polarity for voltages, means that may be addition or subtraction. When it is addition, plus is connected to plus subtraction, minus is connected to minus subtraction, plus with minus or minus with plus, it will be addition for voltages. For currents, both currents are in the same direction, addition. One is upside, another one is downside, it will be subtraction, right? Now I am writing KVL for this one. I write it as the current as I. You all know that current entering terminal is taken as positive. Now the current is entering here. This is plus minus. Yes, coming. This is plus minus, and this is plus minus. That way current is flowing. That's why we are taking it as current entering terminal. Current entering terminal we take it as positive. Right? Now write the KVL. What is the KVL? I am starting here. Sir, how to write KVL? You start at a point, but you must enter the same point. What is KVL? Sum of all the voltages in a closed path must be equal to 0. But how to do the sum according to its polarity? Means if you start at negative, that negative must be taken into consideration. When you are going forward, which sign you are encountering, that sign should be taken into consideration. So I am writing minus E2. I start here. What is that? Minus E2 plus I into, what is the voltage drop in a resistance? Current into resistance. I into, how much is the resistance? 1 minus of E1 plus 0.5 into I plus 1 into I plus E3 is equals to how much? 0. E3 is equal to how much? 0. Now observe here, minus E2 minus 6 plus I don't know, plus minus E1 is how much? E1 is 3 plus 0.5I, yes, plus I plus E3. How much is E3? 6 is equal to 0. Yes, 6 is equal to 0. I, yes, I plus I, 2I, this is 2.5I. 2.5I is equal to minus 6 minus 3 is minus 9, or plus 6 minus 6 gone, it is 3. Then how much is I? I is equal to 3 divided by 2.5, 10 by 4 I will write. How much it is? 12 divided by 10, it is simply 1.2 amperes. How much it is? 1.2 amperes. Sir, he asked about voltage, why you find the current? Yes, current also will get now easily. Now, I'll assume this as a closed path. I don't know V. I'll start at this minus. I'm writing KVL for this one. Minus V, I don't know. Plus, this way. Plus 1 into I. I is how much? 1.2 plus E3. E3 is how much? 6 is equal to 0. From this one, V is equal to 7.2 volts. So people will ask, sir, this is not forming a closed path. We are taking it as a closed path. Right? Closed path need not to be, definitely it must have, for volt, see for current definitely there must be a closed path for the flow of current. But here for voltage, yes, any path we can take and we will make a closed path. Right? Sir, why you wrote this way? You can write this way also. Now, yes, I can write that way also and I'll get the same answer. You can check for that whether you're getting the same answer or not. 7.2 volts is the resultant voltage we got. Yes, that is happily there in the option. Our option is B, B for Bombay, that is 7.2 volts. How much it is? 7.2 volts. Right? Let us go to the next question. See, let's go to the next question. Yes. Answer is 7.2 volts. What is saying? What is saying? Let me solve here in this corner. What is saying? A battery with an internal resistance of 2 ohm and an EMF of 4 volts is connected in series to a load resistance, and the terminal voltage falls to 3 volts. It is not 3, it is 3.8. This is 3S it is showing, but it is 3.8. What is saying? There is a battery of internal resistance. First of all, what is the battery voltage? Battery voltage is 4 volts. This is plus, this is minus. And what is internal resistance? 2 ohms. This is connected with a resistance. With a resistance, we don't know. Then this voltage, this terminal voltage is becoming 3.8. He is saying, right? What is the current flowing in the circuit and the value of the load resistance? If you observe, these are the years in which these questions were appeared. The previously taken questions were, few of them are in 2023, few of them are in 2022. Yes, this question is in 2022. Yes, but this question is in 2023 itself. This question is this question was asked in 2023. Okay. Yes. Now come here. Yes, observe all of you. Now he's asking how much is the current and how much is the resistance value. I is equal to dash, R is equal to dash. As I told you, current is equal to voltage. What is the voltage? 4 minus 3.8. Yeah, this side is 4, this side is 3.8 by 2. How much it is? 0.2 divided by 2, it is 0.1 amperes. Yes. How much it is? 0.1 amperes the current is. Current, Ohm's law. What Ohm's law says? Current is equal to voltage difference divided by resistance. Voltage difference divided by resistance. Yes. Here, see this resistance I am considering. Here the voltage is 4. Here the voltage is 3.8. That difference is 0.2. That difference is what? 0.2. Now it is 0.1 ampere. Now then, what is the voltage across resistor? See, voltage across the resistance is equal to, what is the formula? Resistance into current through it. What is the voltage across resistance? He given in the data 3.8. Resistance we don't know, sir. How much is I? 0.1. Now from this one I can say that R is equal to 3.8 divided by 0.1, that is equal to 38 ohms. So it is 0.1 and 38. Option is B for Bombay. Option is B for Bombay. Yes, 0.1 amperes and 38 ohms. Right? 38 ohms. Clear? Let's go to the next question. Let's go to the next question. Yes, what is this question? Fourth question it is. All the questions we are going to solve. All the questions till 2023 from this current electricity chapter. We already saw that electrostatics questions, then this is from current electricity, right? Now what is saying? Consider two wires AB and CD of length 2L. It is 2L and L. See, there is wire 1. See, let me write it as wire 1. Here it has wire 2. Wire 2. Wire 1 length is 2L. Wire 2 length is L. Okay. Radius. This radius is R. This radius is 2R. Then its resistivity is rho. Its resistivity is 2 rho. Now, what is the resistance of this AB? Not wire 1. This is wire AB. This is wire CD. Wire CD. RAB is equal to rho. Rho is rho only. L is 2L by A. A is pi r square. Na? Why? Area. See, this conductor will be in the form of cylinder. Cylinder cross section area is pi r square. Right? Now, what is its radius? Its resistance. Sorry. RCD is equal to rho is 2 rho. L is L by pi. R square is 2R square. 2R whole square. Now, observe here. RAB is equal to 2 rho L by pi r square. RCD is equal to, yes, how much it is? Rho L by pi r square into 1 by 2. Into 1 by 2. If you see, if I divide this RAB and RCD, what I get? What is this? 2 rho L by pi r square by means 2 pi r square by rho L. Rho L, pi r square gone. It is 4. How much it is? 4. We got some relationship between the resistances, that is RAB by RCD is equal to 4. So from this one, RAB is equal to 4 times of RCD. This is what we got. And from Ohm's law, what Ohm's law says? I is equal to V by R From this one I can say I is inversely proportional to resistance. Now RAB is 4 times of RCD, then IAB is 1 by 4 times of ICD. Yes, the AB current is 1 by 4th of CD current. Why? AB resistance is 4 times of CD resistance. That's why if if resistance is doubled, current will be halved. Right? Now, what is this IAB by ICD? IAB by ICD is equal to 1 by 4. Yes, you can see that IAB by ICD is what? 1 by 4. Option is C. C for Chennai. Right? Very simple question it is. All the questions are very simple, but if you know the concept, then they are simple. Otherwise, they are difficult. Right? That's why learning concept in right direction is very, very important. Now, this question, 5th question, no, we are going to solve in more simple way. Okay, say many people will do in many methods, but my method is going to be completely different. Okay. Now, what is this question number 5? He is saying that there are 3 resistors, R1, R2 and R3 have their resistance values in the ratio 2:3:4. They are combined in parallel and their equivalent resistance is 24 ohms. Then the individual resistances R1, R2 and R3 are. So you check which resistors are having 2:3:4 ratio. Yes, yeah, this is falling. If I take 3 twos, sorry, yeah, if 3 twos, 3 threes, 3 fours, yes, this is falling in this ratio. Next, this also you check 26 twos, 26 threes, 26 fours, this also falling. You check 3 threes it is going, 3 nines it is going, 3 12s it is going, but and 3 again if you see, or directly you take 9, directly you take 9. Yes, directly if I take 9, 9 ones, 9 threes, 9 fours, it is not correct. Now you check this one, 5 twos, 5 threes, 5 fours. So option A, B and D are falling. But in those 3 options, which option is correct, sir? I will tell you very simply. For that, one simple concept I am taking. If I take 1 in parallel with 10, 2 resistances I am taking, that is 1 in parallel with 10. What is that? 1 into 10 by 1 plus 10, that is 11. If there are 2 resistances in parallel, yes, what is the formula? R1, R2 by R1 plus R2. I am taking R1 and R2 parallel. This is the symbol for parallel. R1, R2 by R1 plus R2. How much it is? 10 by 11. 10 by 11 means definitely it is less than 1. Suppose I am taking 2 in parallel with 20, then how much I am going to get? 2 into 20 by 2 plus 20, that is 22, that is 40 divided by 22. Definitely this is less than 2. 40 divided by 20 is 2, but 40 divided by 22 is less than 2. Last one, 10 in parallel with 1000, let me take, then how much it is? 10 into 1000 means 10 to the power of 4 by 10 plus 1000, how much it is? 1010. Definitely this will be less than 10. What is our observation? What is observation? If I am taking very important note point, let me give the observation, then I give the note point. What is observation? One big resistance, one small resistance, one big, one small, one big, one small. Then the resultant will be less than that of the small resistance. What are the small resistance that is there in the parallel combination? No, then the resultant resistance will be less than that of the small or least resistance. Here it is less than 2. So least value is 2. So answer is less than 2. Least value is 10. Answer is less than 10. Now come here. All of you observe in this question. What are, see here, what is saying? The equivalent resistance is 24. Means there are 3 parallel resistances. Their equivalent is 24. Means one of the resistance in those 3 resistance will be above 24. Why? Because the equivalent resistance is less than that of the least resistance in the combination. Must be greater than 24, one of the resistance. Option A is wrong. Why? None of the resistance is greater than 24. Option B, we hold it. Option C anyhow already eliminated. Option C is anyhow eliminated. Now look at option D. In option D, yes, none of them are more than 24. Therefore, already C we eliminated. In A, B and D, A, D are eliminated. Therefore, our option is B. This is one of the way. Another way for the same question is Another way for same question is, if there are three parallel resistances or any number of parallel resistances are there, this is R1, this is R2, this is R3, and this is R equivalent. What is the formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is R equivalent? That fellow given 24. That is equal to 1 by R1 plus 1 by R2 plus 1 by R3. But what that fellow told, one more thing to us, that is that R1 is to R2 is to R3 is 2 is to 3 is to 4, means can I write R1 by R2 is equal to 2 by 3. So from this one, R1 is equal to 2 R2 by 3. This is 1. Yes, and R1 is to R3 is equal to 2 is to 4, right? R1 by R3 is equal to 2 by 4. Now from this one I need to get R2. Okay, what I'll do with R1? So R2 is equal to 3 by 2 times of R1. Here also R3 is equal to 4 by 2 times of R1. Now here in this you replace R2 with this one, means with R1, replace R3 with this value. Then total equation is going to be in terms of your R1, then you will get the R1, then R2, then R3, right? This is how we have to solve. Yes. So answer is, if you solve it this way, but this is the lengthiest way. With the method what I told, yes, it is very easy for you to solve. What is the note point? I thought of giving note point to you. Yes, what is the note point? What is the note point? If n resistors are in parallel, then the equivalent resistance is less than that of least resistance. That is the statement, right? Yes, let's go to the next question. See here, this method is very, very lengthy. Do this, that, all that, not required. If you understand that statement, that is done, right? Next question is about potentiometer. What that fellow says: a potentiometer wire of length 100 centimeters has a resistance of 30 ohms. Means there is a 100 centimeters wire, its resistance is 30 ohms, right? Then for 1 centimeter, how much it is? 30 by 100, na? For 1 centimeter, it is what? 30 by 100. Okay, it is connected in series with a resistance of 20 ohms and an accumulator EMF of 10 volts having negligible internal resistance. He is saying that he is connecting this one in series with, let me draw, in series with, yes, how much? It is connected in series with a 20 ohms and an accumulator EMF of 10 volts. This is 20 volts, so 20 ohms, and this voltage is how much? How much is saying? 10 volts. Okay. A source of 2.4 volts is balanced against length of L. He is saying that 2.4 volts is balanced against a length of L. Then what is the length L? We all know that both are in series. Series means current will be same. Then what is the current in this one? 10 divided by 20. The current is 0.2 amperes. 0.2 amperes. Now observe. See, current is 0.2. Total resistance is 30. Total resistance is, this is 30 plus 20. 50 ohms is the total resistance. And the second one length is not mentioned. We are least bothered. Okay. Now tell me, 0.2 is the current. 0.2 into resistance is equal to 2.4 volts. Then how much is resistance? Resistance is 2.4 divided by 0.2. 24 by 2, that is 12 ohm. Total resistance. Now 100 centimeters 30 ohms means 100 centimeters 30 ohm means, yes, 12 ohm means how many centimeters? X we take. So 100 into 12 is equal to 30x. Now this gone. So x is equal to 3/4 cities. How much it is? 40 centimeter. Answer is how much? 40 centimeters. That much simple it is. For 100 centimeters, 30 ohms. For 12 ohms, why 12 ohms? What is the voltage is saying? 2.4. What is the voltage drop formula? Resistance into current. Sir, how do you know the current? This is 20 ohm and 10 volt. 10 divided by current is equal to voltage divided by resistance. Voltage is 10, resistance is 20. How much it is? 0.2. Sir, why the same current is flowing here? Both are connected in series, right? Option is B for Bombay, right? Next question, please. What is the next question he's saying? Saying that two batteries of EMF E1 and E2 are connected in parallel by connecting their positive terminals to point A. Okay, he's saying this way he is connecting. Yes, this way he connected. This is A and this is B, right? Then he's saying a third battery E3 is connected in series with this combination. Okay, in series with this combination by connecting its positive terminal to the point B. Okay, yes, this is some resistance. Now, what is the equivalent combination of this EMF is? What is this value? 6. What is this? 0.5 ohms. What is this? 12. And what is this? 1. And what is this? Yes. What is this value? E3. E3 is 6. This is 2/3. What to do is find its EMF. Find its EMF. How to find? In this closed path, current is flowing. In this closed path, current of I is flowing. Therefore, this will be plus, this will be minus, this will be plus, this will be minus. Write the KVL. This is minus, this is plus, this is minus, this is plus. Write the KVL. Minus 12 plus I plus 0.5 I plus 6 is equal to 0. Right? Then minus 6 plus 1.5 I, yes, is equal to 0. Therefore 1.5 I is equal to 6. So I is equal to 6 divided by 3/2 into 2/3. 3 2's I is equal to simply 4 amperes. I is how much? 4 amperes. Let's understand, or let's take this voltage as voltage V. Write the KVL now for that loop, that assumed loop which is not there. So minus 12 plus I plus V is equal to 0. Therefore, V is equal to 12 minus I is a 4. So, V is equal to how much? 8 volts. So, this total combination is of 8 volts and this is already having here 6 volts. Therefore, 8 plus 6, total voltage is equal to 8 volts plus 6 volts is equal to how much ma? 14 volts. How much it is? 14 volts. C for Chennai. Option is what? C. Option C. C for Chennai. Right? Next question, please. Next question. What is saying? Consider two cells of EMF epsilon 1 and epsilon 2 with internal resistances R1 and R2 respectively. These two cells are connected in parallel by connecting their positive terminals together and connecting their negative terminals together. Okay. The combination of this equivalent to a single cell with EMF is given by. He is saying very simply, there is a resistance and EMF. There is a resistance and EMF. Yes. This is R1 epsilon 1, R2 epsilon 2 or E2, whatever it is. Now he is saying that this combination is represented with a equivalent resistance and equivalent EMF. What is this R equivalent and epsilon equivalent? He is asking. Right? R equivalent and epsilon equivalent. Now, yes, see, for this one what I do is convert this voltage into current. How? A voltage in series with a resistance will be converted current in parallel with resistance this way. The current value is epsilon by R1 and the resistance is R1 only. Yes. A voltage in series with resistance will be converted to current in parallel with resistance and vice versa. This also, yes, resistance is R2 only. Then what is this current? This current is what? Epsilon 2 by R2, right? And we all know one thing. That currents in parallel will get add. What is the total current then? This is epsilon 1 by R1 plus epsilon 2 by R2. And what is this parallel combination? R1 R2 by R1 plus R2, right? Now voltage in parallel with resistance will be converted to, again vice versa. See, a voltage in series with resistance will be converted to current in parallel with resistance. What is vice versa? Current in parallel with resistance will be converted to voltage in series with the resistance, right? Now if you want voltage, no, multiply the current into resistance. What is that? This resistance is R1 R2 by R1 plus R2. Then what is this? This is R equivalent. This is R equivalent. Then what is this epsilon equivalent? Current into resistance. What is our current? Epsilon 1 R2 plus epsilon 2 R1 by R1 R2 into R1 R2 by R1 plus R2. This R1 R2 gone. This is epsilon 1 R2 plus epsilon 2 R1 by R1 plus R2. So this is the equivalent EMF. Epsilon 1 R2 plus epsilon 2 R1 by R1 plus R2. Right? Come here. Yes. What is this? Epsilon 1 R2 plus epsilon 2 R1 by R1 plus R2. Option B. B for Bombay. Right? Let's go to the next question. See, here there is lot of solution. All that is not required. Very simple. See, this method is also correct. See, I'm not saying that this method is incorrect. That method is also correct. But my method is this. See, that method also mine. Okay, but in two different ways I'm solving. Anyhow, that solution is visible to you. You can see that. Yeah. He is saying that suppose you mention the resistivity of an alloy as R alloy, which is made up of two metals. Alloy means combination of two metals. Okay, A and B, and the resistivity of the constituent metals are denoted by Ra and Rb. Which of the following relations are true? See, we need not to see the any options. Alloy resistance is always greater than their individual resistances. Alloy resistivity in fact is greater than the individual metals resistance or resistivity, right? Yeah, that is direct statement. It is direct statement. So which one will be the option? Which one will be the option? Yes, the option is, yeah, R alloy is greater than Ra and R alloy is greater than Rb. Yes, R alloy is greater than Ra, R alloy is greater than Rb, right? Now, for that all this explanation is not required. That is a simple straightforward statement. What is saying? Two resistors R1 and R2 have their resistance values in the ratio of 3:5. Okay, R1 by R2 is equal to 3 by 5. Fine. And are combined, then the equivalent resistance is 24. Means R1 plus R2 is equal to 24. Now from this one simply 5R1 is equal to 3 times of R2. From this one R1 is equal to 3R2 by 5. Substitute there. Yes, R1 is R1 only. R2 is R1 I found. Okay. In the place of R1 you substitute 3R2 by 5 plus R2 is equal to 24. But 8R2 by 5 is equal to 24. 8 3s it is. From this one R2 is equal to 15. Total is R1 plus R2 is equal to 24. R1 plus 15 is equal to 24. Then R1 is 9 ohms. This is 15 ohms. 9 and 15. This is a direct and simple question. Option is C. C for Chennai. Right? Yes. This is a direct question. Ratios is given and equivalent is given. Series means both the resistance will be added. Clear? Next question please. Next question. What is saying? A galvanometer coil has a resistance of 14 ohms and meter shows full scale deflection of the current 4 milliamperes. How will you convert the meter into voltmeter of range 0 to 16 volts? See, there is a galvanometer which is having resistance of 14 ohms. Now how much is the current that is flowing in this? 4 milliamperes. Now what is the voltage it can withstand? Voltage of the galvanometer is voltage is equal to current 4 milli into resistance 14. Yes, how much it is? 14 fourths 56. Yes, 56 millivolts only it can withstand. But he want what? 16 volts. He want a 16 volts galvanometer or voltmeter. 16 volts voltmeter he want. Right? Now what the total voltage you want? Total voltage is equal to 16 volts. Galvanometer can withstand 56 millivolts plus some that extra that will be same current. See, if more than 4 milliamperes is flowing through the galvanometer will die. Therefore current will be same. 4 milliamperes into the external resistance you want to keep in series. External resistance. Now what is that? 16 minus 56 millivolts divided by 4 milliamperes is the external resistance. Is the what? External resistance you can calculate. Just you do this calculation. Okay, 16 minus 56 milli divided by 4 milli, right? If you do that, yes, you get the answer, right? Yes, you get the answer. Yeah, observe here carefully, please. Yes, 16 minus, as I told, 16 minus, yes, 16 minus 56 into 10 to the power of minus 3 by 4 into 10 to the power of minus 3, you solve, you get the answer. It has 3986 ohms. Yes, yes, it is going to be how much? 3986. Option as A. Option as A, right? Next question, please. Next question. What he is saying? When an EMF of two cells is compared in a potentiometer experiment, the ratio of the balancing lengths is to be 2:5. Means one L1 is to L2. L1 by L2 is equal to 2/5. Okay. If one of the cell has an EMF of 1.2 volts, then the other cell EMF is, EMF is directly proportional to length. So he's saying that what is L2? L2 is 5 into L1 by 2, means it is 2.5 times of L1. Now E1, see, I can write E1 by E2 is equal to L1 by L2. So from this one I can write E2 is equal to E1 into L2 by L1. So what is E1? 1.2 is saying. Yes, 1.2 is saying. How much is L2? 2.5 times of L1 by L1. L1 gone. How much it is? 2.5 into 1.2. So it is 2.5 plus 0.2, 0.4 plus 0.5 it is, I think. Yes, 2.5 plus 0.5, how much it is? 3 volts. See, 3 volts. But here in two options it is 3 is there. It is 3 volts is here, 3 volts is here. Now what I taken is, I taken E1 as, I taken E1 as 1.2. But if I take E2 as 1.2, see, he said 2 EMFs, E1, E2. He did not mention E1 is 1.2. I taken E1 as 1.2. Suppose if I take E2 as 1.2, then E1 I need to find. If I take E2 as 1.2, then what is the relationship we have? E1 by E2 is equal to, E1 by E2 is equal to L1 by L2. So that 1.2, see E2 we have, how much it is? 1.2. And L2 we have, what is L2? Means at a length of L2, then you have to take L1. If you solve it, you are going to get, see, I will do it here. See, E is directly proportional to L, and L1 is to L2 is equal to 2:5. So L1 by L2 is equal to 2/5 we got, right? So at a length of L1, yes, from this one E1 by E2 is equal to, yes, L1 by L2. Previously I taken E1 as 1.2 for L1, right? E1 as 1.2 for L1. Now I am taking E2 as 1.2. Now tell me, E1 by 1.2 is equal to L1, keep it as L1 only. What is L1 by L2? L1 by L2 is 2.5. Then L2 is what? L2 is 5 by 2. Yes, 5 by 2 times of L1. Now E1 is equal to this gone. 1.2 by 2.5, almost is 0.4 change you get, that is 0.48 volts. Means the answer is either 3 or 0.48. Option B for Bombay is going to be suitable, right? Means even E2 he told, but which one is E1, which one is E2 he did not told. He given one voltage as 1.2. If I assume that E1 as 1.2, then E2 will be 3. If I assume that as E2, then E1 will be 0.48, right? Let's go to the next question, please. So he's saying that there are 3 batteries of internal resistance connected as shown in figure. The equivalent EMF and the internal resistance of the circuit between terminals A and B is equal to. He is saying, see, this is given very simple, as I told you. This is voltage source in series with resistance converted as current source in parallel with the resistance. What is the current value? 2 divided by 0.1. This is 20, and the resistance is of 0.1. First one. Second one is 4.2, but current direction is this way. Why? The voltage plus is this here. Here is the plus, right? That's why this is the direction. 4 divided by 0.2. It is also 20, and the resistance is 0.2. This is the last third one. Third one is yes. What is that? 6 divided by 0.2, that is 30. 30 will be this direction. Yes, and the resistance of 0.2 and the resistance of 0.2, right? Right. Now this 20 gone. I am left with only 30. I am left with only 30 amperes, right? Now 3 resistors are in parallel. What are those? 0.1, another 0.1, sorry 0.2, and another 0.2, another 0.2. There are 3 resistances in parallel. 3 resistance in parallel, if you do, how much you are going to get? What is the formula? R equivalent is equal to, in fact 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? If you simplify it, R equivalent is equal to R1 R2 R3 by R1 R2 plus R2 R3 plus R3 R1. If you get, if you substitute all these values, you are going to get 0.05. Now you got this one. What we got? There is a current source of 30 or current of 30 in parallel with 0.05. If you convert this one, 30 into 0.05 will be, how much it is? 1.5 volt. 1.5 volts. This is plus minus 1.5 volt with an internal resistance of 0.05 ohms. With an internal resistance of 0.05 ohms. Now the options are there in the next page. Yes, let us see. Let us see what are the options, right? Yeah, options are somewhere here. Yes, just let me go to the options, please. Yes, he given, yes sir, it is a 1.5 volts. Option is this one. This is A, this is B, this is C, and this is D. 1.5 volts with 0.05 ohms in series, right? Let us go to the next question, please. What is saying? What is saying? Yeah, suppose every second 10 to the power of 6 electrons come out of a body and move to another body, then the time required to get a total charge of 3.2 coulombs is 3.2 coulombs. You want Q is equal to 3.2 coulombs. 3.2 coulombs, right? Yes. Here this is one of the simplest question. We all know that total charge of Q is equal to N into E. See, 3.2, this 3.2 is equal to, yes sir, number of electrons that fellow given. How much it is? How many electrons given? Number of electrons? Yes, just a minute. 10 to the power of 16. Yes sir, 10 to the power of 16. But see, I will tell you one of the very simple thing here. First, let's find the current. I is equal to dq by dt. That itself is given by him. What is that? So 10 to the power of 6 electrons in every second. 10 to the power of 16. Sorry. See, what is current? Current I is equal to q by t. Now, from this one, t is equal to q by I. Right? Q is 3.2 coulombs. Right? 3.2 coulombs. I is 10 to, see, what is I? 10 to the power of 16. But this 3.2, it is coulombs. 3.2 means what? What is the total charge? What is the total charge? Let me write here. That is N into E. What is N into E? Right? From 3.2 coulombs, N into 1 electron charge is what? 1.602 into 10 to the power of minus 19. From this you get it as N is equal to what? 3.2 divided by 1.602 into 10 to the power of minus 19. Now this will be almost, this will be 2 times. This is 2 into 10 to the power of 19. Right? So this is 2 into 10 to the power of 19 divided by 10 to the power of 16. That is how much? Simply 2000 seconds. Simply 2000 seconds. I is equal to Q by T. I want a T. T is equal to Q by I. What is Q? Total charge. But that is number of electrons into charge. Number of electrons into 1 electron charge. So number of electrons, how many I got? 2 into 10 to the power of 19. How many electrons are moving per second? That is nothing but current, right? That is nothing but current. Answer is 2000. Option is D. It is C, please. It is C. It's a typo. That is C. Right? Let's go to the next question. This question is asked in 2023. Simply, this is KVL. Is asking about KVL. What is saying? What is the resulting equation when Kirchhoff's loop law is applied to the following closed loop? AD EFA, ADE, this is not B, this is E, ADEFA. With B closed loop is not possible anyhow. ADEFA. EFA. As I told you, current entering terminal is taken as positive. Yes, now if you enter here, yes, I6 into R6, I6 into R6, right? Yes, I6 into R6. Next, minus I6 into R6 minus E2. Why I am entering here? See here, this is I6, please. This is I6, this is plus, this is minus. Therefore, plus I6 into E6 minus E2 plus I4 into R4 plus I5 into R5 minus E. Yes, this is not clearly visible to you, right? This is E1, this is E2, this is E3, please. Minus E3, minus E3, minus, why minus? This is plus, this is minus, I1 into R1. Therefore, minus I1 into R1 is equal to 0. Now, yes, I6 R6 plus I4 R4, yes, plus I5 R5 minus I1 R1 is equal to E2 plus E3. E2 plus E3. Check it clearly. Check it very clearly. See, these are looking somewhat small, but see, this is current I6. This is current I6. Okay. We want only this loop. This is A. This is D. This is E. This is F. This loop only. This is R1. This current is I1. This is E3. As I mentioned, this is R5, this is I5, this is R4, this is I4, this is E2. Right? Now this easily you can get it, right? Easily you can get it. Observe which option is satisfying. I6 R6 plus I4 R4 plus I5 R5 minus I1 R1 is equal to E2 plus E3. That is option B. B for Bombay is perfectly suitable for the given question, right? What is Kirchhoff's voltage law? Sum of all the voltage in a closed path must be equal to 0, right? Yes. Now, this question is also asked in 2023, this question number 16. What is saying? The resistance R of a wire is determined by measuring the potential difference V across it when the current I is passed through it. The percentage error in the measurement of V and I are 5% and 3% respectively. Then the percentage error in the resultant of the R is. So, R is equal to V by I. But here is error of 5%. In this error of 3%, right? So these errors are getting divided in the formula. Then the total error, see, total error in the R is equal to 5% plus 3%. Total it is 8%. This is very simple concepts. Errors will get directly add. So option is D for Delhi. D for Delhi. That much simple it is. See, these are all the previously asked questions from the topic current electricity. We are done with that. With this, see, we are done with the electrostatics and current electricity, right?